Hello, everyone. My name is Marcus Merrell, and I'm here with Alistair Heys to present a session about testing better with data, using our new failure analysis tool to focus testing on the efforts that'll bring you the highest reward the quickest. My name is Marcus Merrell. I'm the Senior Director of Field Services for Sauce Labs, and my responsibility is to help our customers implement our product successfully, whatever that means. I would like to introduce Alistair Heys, or let him introduce himself, in fact. He's a senior product manager at Sauce Labs.
Hi, everyone. Thanks, Marcus. My name is Alistair Heys. I am a product manager at Sauce Labs based out of the Vancouver office. I am responsible for our insights portion of the product, so that's reporting, dashboarding, and then as you'll see, some advanced analysis and solutions that we're starting to provide and invest in. I've been working in the software development space for coming on 10 years in financial services and retail software systems primarily. And now coming full circle from my original days of being a tester myself to working for a company that's providing testing software.
Great. Thank you, Alistair. So before we get started to talk about the actual solution, I want to help to try to define the problem a little bit. I've been a tester for 20 years, and in automated testing actually for the entire time. I've been a manual tester when I've had to be, but mostly I'm an automated tester at heart. API testing, UI testing, I've been using Selenium for about 12 years since it was announced at GTAC in 2008. So I've seen a lot of flaky tests, I've seen a lot of failures, I've seen a lot of companies and teams accept the fact or the idea that there are a lot of failures that are just sort of inevitable while using Selenium. That leads to a lot of noise in your test automation program, and it leads you a lot of times to where you don't really understand what is signal, what is noise. And if I'm just tolerating a level of failure every day, then there's a certain amount of analysis I have to go through every day just to find out what happened in my test suite. What we're trying to do is really utilize the data that we see flowing in and out of our software every single day. Because if you think about it, we've got billions of tests we've run that have been executed on our platform. Data is being sent through all of these things. And if we apply a little bit of machine learning, a little bit of artificial intelligence, we can actually gather up some of this stuff and hand it to you and say, we believe that these conclusions can be reached based on the data that we're seeing in your historical test suites. So what I wanted to see, I wanted to encourage people to give me a +1 or a yes in the chat room if this story sounds familiar to you. Imagine that you're part of a team and you've been working on a Selenium suite for a while, and at some point you start to get failures on a daily basis. When you get to a couple hundred tests, there's a few that fail every day, some of them consistently, some of them day in and day out, some of them you don't really know. But at some point, somebody on the team, maybe it's a rotating responsibility, maybe it's the newest person on the team, their job is to sit and analyze the failed tests every day and to have a look at the different builds that went on and to see what happened and to basically come up with what is the signal that's coming through all of this noise in these test failures. So in my experience, that has been a person's job. And what we're trying to do at Sauce Labs is help that person and that team to understand exactly when I come into work this morning, what is my eye being drawn to, and what are the actions I need to take to solve these problems the best? So you see a report full of the failing builds. You then go to Eclipse and you start to look at the failures themselves and analyze each one. Let's take an ultra simplified view and sort of get an idea of what you look at. When you first look at it, you see just this pool of data: 5 passed tests, 9 failed tests. Okay, I don't know what's going on here. I don't have any idea. First of all, if I'm the test failure person, I don't even know what to call it. I feel like this role needs a name on the team. Maybe in the chat, y'all can suggest names for the person who does this job. But as this person, I don't care about tests that pass. Those are all signal. And that's a good one. Unlucky. So if you're Mr. or Mrs. Unlucky, you don't care about the tests that pass. You are the person who, you just care about the failure. You assume that tests that pass are passing tests and they actually are accurate, and that they don't figure into the calculus of how you have to operate in the morning. So let's eliminate the passing tests and let's look at the failures. We see element not found in the login button. It's just not there. Then we see a test that fails with a 504 bad gateway. Then we see a good old friend stale element reference exception. Then we see another 504, then we see another 504 and another 504, and we're starting to think to ourselves, there's a pattern here. Then we see another element not found. Well, that looks like the first one we looked at. Well, and then there's another element not found, another 504. Well, let's use our human brain to consolidate this a little bit. Let's group these errors a little bit. So there's an element not found. There's a couple 504s. Let's do a slightly better job of grouping, because this is probably what your first pass looks like. Here's your second pass of grouping. I know that now that there are 3 element not founds, 5 504 bad gateways, and 1 stale element reference exception. And now I'm going to do the final iteration of my grouping, and I'm going to say, here's my daily job. And I know now that a 504, if I fix that, then those 5 failures, either they go away or they go away to unmask the next failure, but hopefully they go away. And you, by fixing one thing, you have fixed all 5 of those tests. So we know that from our Selenium backgrounds, we know, and if you don't know, I'm here to tell you, stale element reference exception is always an indicator of faulty automation code. It means that you got a reference to something in the DOM, and then the DOM changed, and then you tried to act upon that web element once again. So it's always a problem with faulty automation code. This is something that you can fix inside your code stack, and it doesn't have anything to do with the product or the developers, and you know that. And you know that that one failure is caused by that one problem, and since it's only one failure, maybe you can ignore that for now and go to the higher priority item around the element not found. Now, this could be a problem in the product. It could be a change in the product. It could be something where your locator is a little bit flaky, or your weights, your synchronization isn't happening properly. So that could be either in your code or in the product code, and it might actually be a defect you've uncovered. But you've seen it now, you know exactly where it's happened in all 3 of these test cases, and you know that there's a wide range of things that this error pattern covers. Then you go to the 5 that are done by the 504 bad gateway. These tend to indicate environmental issues and poorly deployed APIs or a misdeployed application or some connection that's not being made. The point is that your work is now prioritized. You can see what your day looks like, and you can see the signal within all the noise of the failures that you get. And the exciting thing about this is that Sauce Labs is now rolling out a product that will help you do this work before you even come in the day. This is the work that will be laid out for you, and it'll all be set up for you. So I'm going to let Alistair talk in more detail about it, but this is sort of the exciting new direction that, if you watched Matt Wyman's presentation earlier today, that Sauce Labs is trying to go with all of our software. Alistair?
Thanks, Marcus. So I thought it'd be good at this point to possibly take a step back and look at organizationally, what are we as Sauce Labs focused on at this point in time? And one of the major pieces is providing our customers with analysis and analytics and insight into their delivery risk. So focusing on how do we provide more information and more in-depth information so that people can have a greater confidence in the software they are delivering. So one way in which we looked at this a little while ago is we looked at our continuous testing benchmark. So this is a industry-wide report that we put out once a year. Some of you get to see your numbers slightly more often, and we find it useful to talk through with our customers how are you looking holistically as you look towards being able to do continuous testing. There's 4 main measures, but really the one we're focusing on at the moment is test quality. Now, the reason for that is that without test quality and test quality being defined as the percentage of your tests that pass per execution, the reason why we're really digging into this is something that we've noticed is that a large portion of our clients have a relatively low pass rate for their tests in aggregate. The reason I say relatively low is that about 80% of our clients have a pass rate of under 90%. Or sorry, just over 75, 80. It depends on the time of year. There's big pushes, but what this means is that if we look at it, we say, right, if your average pass rate is below 90%, there's likely noise in your system. The lower you go, likely the more noise there is. As we would expect that a mature testing practice, even if a breaking change happens, it's a smaller set of tests that fail. So our data science team saw this and said, hey, we wonder if there's something we can do about it. Are there particular areas that create a large amount of the noise? how can we help people get this number above 90% to really stop a lot of the tests from causing most of the noise, and then allow customers to focus on other challenges they face. So to give you an idea of the scale of this problem, I took last week's data from all of the virtual jobs we run, so that'd be cross-browser testing in emulators and simulators. And this isn't dissimilar from any other week. It's real numbers with a kind of ballpark average week, and we ran about 17 million tests. About 8.4 million of those passed, 3 million failed, and about 5.7 we don't know, because you don't necessarily have to tell us if a test passed or failed. But if we pull out the test that passed, or sorry, that failed, 3 million tests, even with our customer base and with the size of the customers we have, that's still a lot of tests to have to go through on a manual basis. There's obviously no possible way that someone that a group of individuals can go through anything like that scale. If you're having to assess 27% of your tests that have run, there's a lot less points having automation. So we went down a journey of exploration, and when I say we, I mean primarily our data scientists. They said, is there information in the tests we already have that can help us identify where these failures are happening and why they're happening? And can we share that with our customers in a way that's consumable and easily used by them? So when we started, we did a few different types of analysis on a number of different artifacts. And when I say artifacts, I mean all of the piece of information that we have access to after a test is executed. So that would be Appium and Selenium server logs. That would be if extended debugging is on the HAR files or JS console logs. We have screenshots and image data. We have the metadata from the capabilities that are associated. And what we found is that as we started going through this, it's really tricky to try and pull out the why something happened. We can start clustering tests by that look similar. We put those together and we identified failures that look very similar. But when we took that information to some clients specific to their data and asked us to talk through the results, what they told us was there's not enough detail there. It's okay. It's good to know that these are related, but we need to know why they're related. So after we had to go back to the drawing board there and take a number of different approaches. Off the initial approaches failed. Some of the other things we tried on the more technical side is we looked at how do you compare these different tests against each other. We tried to convert everything to numeric data. That didn't give us a good enough insights into being able to make them look similar. We did regex pattern extraction. That didn't work to give us the sort of granularity we were looking for when being able to identify what happened in the test. But we did find that this did raise, in doing this, it raised a number of problems that we need to bear in mind when we're trying to solve for things like this. And the four main problems that we've got to solve for in this, and we can't just focus on a very small piece of analysis, is that we have scale, velocity, complexity, and variability that create challenges that are fascinating to solve for. And I think what's really interesting is that we saw that if we can solve for these challenges at the scale, velocity, complexity, and variability that we're doing it at, it means that our clients don't have to do it, even if it's a smaller subset, because you run into the same sort of challenges. So, for instance, we're generally running about 60 million tests a month. So if we can operate at that scale, a subset of an individual client makes sense. However, scale between 2 million and 60 million means, yes, additional infrastructure and additional resourcing needed. But even at a scale of 2 million tests a month, it's still significant work just to make sure that you can process that amount of information. In terms of velocity, we typically see on average 2,000 tests a minute that are being completed in our system. This obviously peaks up to about 5,000 tests a minute. So being able to analyze at that sort of speed presents its own set of challenges. And again, for an individual customer, it's the same idea. Complexity, as you can imagine, even for a large organization, different teams use different setups. They use different environments with different frameworks and test languages. And it's just one of those things to consider. So when we looked at what we're trying to solve for, we said, okay, maybe we can't solve identifying failures across every single customer in every single instance, but let's try and pick a way of doing it. Let's try and figure out a way that at least covers a large percentage of the tests that are run within our system. So when we're looking at complexity, it started narrowing down on the types of information we could use to drive the analysis. And then in terms of variability, I think this is one where it's really interesting. As we look into this, we're still investigating, but we look and we say, okay, we could probably do some work and try and pick out specific errors. Like, okay, I see a 404 error. Can we surface that to customers? We look and we go, okay, yeah, that seems reasonable. There's probably a couple of different ways we can do it. It's probably something we will build at some point. But what we're really looking for with this solution is to start building a solution that can sit across a wide variety of scenarios. So to give you one example, what I mean by variability is in one particular instance for a customer, we looked at 1,263 test executions, so individual runs of the same test being the same test name. Within that meant that almost half a million lines of Selenium logs were executed, so commands were executed. It contained 83,000 unique paths, 28,000 unique requests, and 45,000 unique results. And obviously this was only hitting 5 different URLs. So what we really needed to do was to get a way of taking this immense complexity and variability and simplifying it so that we can communicate that back to the user, so there's useful information to go on. So in doing this, we've so far found 3 different approaches that we think have or that we've shown to have enough viability to start moving forward with this product. The first piece that we've looked at and is an interesting angle on it is analyzing the end state of a test. So our best approximation of where a test failed, and comparing that visual state to other tests that have failed and end up in a similar state, and looking to link the individual executions and test names in that basis. What we found is that there's definitely some applications for this type of thinking and methodology that it works really well for. So a missing QA resource, for instance, seems to have really good applications where it'll be able to pick up, say, a bad gateway error in the browser. Other applications, not so much. As all of you know, not all failures manifest themselves visually. So it's, there are shortcomings, but this is a path we're investigating and continue to investigate as we look to improve our product and suite and tool set overall. The second approach we've seen we believe we have traction with, is taking a slightly different model. Taking a test that's failed, looking at a test that's passed, and doing that at scale, but then looking at each individual command and ranking those against each other to say, what is the probability of any given command being the cause of the failure in the test? What's really interesting about this is the way we initially did the research is we created 2 models. One that looks at, for a given test, what's the relative ranking of that probability, but then also a model that takes the global, and by global I mean within an organization, view of all the commands, so it gives it a ranking within that organization. And the reason we did this is we're trying to understand ways in which the information we best served up. So possibly looking at things like what commands have a high degree of certainty or the underlying issue, and which of those can we make easily accessible to our customers so that they can come in and solve those as quickly as possible. Which are the most widely spread commands that are leading to these failures, and at what scale, so that they can fix them. This brings me to our third piece that has legs, and this is in fact the piece of underlying logic and the model we're using that's in the product today. and that's called failure analysis. So what this model does is it looks at Selenium and Appium logs. It looks at the server log with each command. It compares them against each other and looks for differences in a test that is passed versus failed. So it looks and says, right, these are the 3 lines that are different from these other lines. And what it tries to do is work out which lines are irrelevant that they're different and which lines are indicative of a failure. And the way it does this is it leverages some machine learning with a couple of pretty smart algorithms that we've learned and adjusted and tweaked. And what it does is, by looking at these at scale, so at 2 million tests, at 60 million tests a month, but even within organizations at a couple 100,000 tests, it can start picking up and learning exactly where those issues might be, and will get better and better over time as we go. So one really interesting thing here is that we ran our algorithms of the failure analysis to pull out the what we call failure patterns, which would be the sequential and non-sequential set of Selenium and Appium commands. And we ran it against a subset of customer data coming in. And what we found is, over the course of analyzing 3 million tests, we found that on average, for any given test, 27% of failures can be associated with one single failure pattern. Now, that's not to say it's perfect, but it gave us a really good indication that we're on the right track, that if we can start isolating failures for any given test to a small subset of failure patterns, and then with the ability to link up the failure patterns across tests, we believe there's large economies of scale to gain from being able to link that information both across tests, but within tests and test executions themselves. To give you an idea, that the same analysis was done, and if we look at, for any given test, the top 5 reasons account for over 60% of failures. So our belief and hope that is that we'll start being able to drastically improve the pass rate of test suites and individual tests and therefore systems by improving a relatively small set of or fixing a relatively small set of problems. So we have our new feature that is in the product. It's called failure analysis. We have 3 main views of it. One is by test name, so you can come and you can say, I want to see the test that's causing the biggest impact right now to my test suite, or for a given period or team or user, and you can drill right in to see the underlying failure patterns associated with it, which is the select set of Selenium or Appium commands, and then drill down to individual test executions, see the failure pattern in the context of that test, hopefully debug it, come back, rename it. We have another view on the same sort of information broken down by build. So in the context of an automated build, you can come in and see that, okay, these are the failure patterns associated. You can name them, so in that way there's a context to it. So if you know it's a bad gateway error, then the next time you come in, you should be able to see that, hey, these are bad gateway. Oh, I had 150 tests out of 2,000 run in this build that are associated with that. And hopefully through this, it will not only allow you to understand where the failures are coming from, but really start quantifying them and provide that information back to either your own team or in some cases other teams within your organization to communicate the scale of the problem, and thus work together to get those resolved. So right now this feature is in a very early access mode. We have some clients using it. We're continuing to onboard clients. So if you are interested in getting access, reach out to your CSM or email failureanalysis@saucelabs.com, and we'd love to get you up and running on it and using it. Marcus, I think we might have some questions. Do you want to take over from here?
Yeah, sure. Let's take over. I just want to say again, I think that this is exciting new direction for Sauce, as well as it is still a little early, and it's still an area that we're just now sort of getting into and investigating. But I also want to point out that there is a little bit of lift on your part, which you should be doing already, sending us pass-fail results as well as good solid test names. in the metadata that you set up with your capabilities. But if you do that, then eventually this stuff will just start working automatically for you. This is also a complementary with your contract. This is not an extra charge for this service. With that, are there any questions?
Maybe while we wait for the questions to come in, one other piece of information is if you'd like more information about this or you want to see it in more depth, I am doing a demo that starts in about 20 minutes or 15 minutes around not just this individual feature, but the rest of our test insights too. And insights are different reporting, dashboarding, things like that. So feel free to come in there too if you'd like to see it in more depth. Yeah, I think one thing that might be worth discussing, Marcus, is that comes to mind for me anyways. What does this work for? That was a pretty big question that came up a couple of times. So as of right now, failure analysis works for emusim and cross-browser testing. So that's VDC or virtual desktop cloud. And it's any test that runs an Appium test or a Selenium test. We have the desire to add RDC. That should be coming later towards the end of the year. We will look and assess as to what other frameworks or languages or test suites we'll add as we continue to improve and expand the offering.
There is a question, Alistair, that I don't want to read to you. It's a long one. How does analysis work when there are multiple tests within a spec? Meaning, Ruchi, is that spec meaning cucumber? BDD? I think, yeah. That's interesting. That's WebDriver IO spec, yeah. So it's a behavior-driven test. And the truth is, we may not know how the behavior-driven piece of the test is laid out because all we get are the WebDriver IO commands that get sent to us. And so there's going to be some correlation that's done, but it depends on how the test is broken up and how they're grouped together by test name. Maybe Alistair has a better answer.
Yeah, I don't have a good answer for that right now. Really, it's going to look through. Yeah, I think
we could, Ruchi would be glad to field that question offline because that's a very interesting. I think that's probably another iteration or two away from where we are right now. This is an early on product.
Yeah, I think it's really interesting. I'd like to understand more about what the Selenium and Appium or Selenium commands look like when they come through in those scenarios. Does each set look drastically different, or do they look similar? And yeah, I think that's probably what it'll hinge on, because at the moment it is really just being driven by looking for patterns in those commands. Yeah.
Okay. Great. That sounds good. So I think we're being given the 3-minute warning. We have until 48 after. Is there anything else we want to cover? If anyone wants to go lightning fast, they can type in a question. I just can't say enough about how excited I am about this feature. In a lot of ways, this is the reason I came to work for this company, is because recognizing the opportunity to surface this kind of data that was such a pain for me back when I was in QA and a QA manager. So I really appreciate Alistair taking this on to the extent that he has. Will it be available for everyone not enterprise now? I believe the answer is no. We do not. We typically haven't seen the volume of data that you'd need in order to form a critical mass. The AI and ML processes, they need to have enough data to make an opinion on. And typically we don't see the kind of volumes that we would need to see in order to make those conclusions outside of the enterprise accounts. It's certainly worth a question, but at this point it's not available.
I think another good point, Marcus, is as of today, we did include self-service customers or non-enterprise customers in Insights. So there are 3 reports: test overview, test history, and trends, which will hopefully at least start you on that journey with more information. And then we'll continue to assess when we feel confident that for a given volume of data, it would make sense to enable a feature like this.
Great. Does the platform extend to mobile framework? In a limited way, it does. What was the answer, Alistair? Was it EmuSim with Appium? Is that correct?
Yeah, so right now, EmuSim with Appium. And then we'll look to extend that to our real device cloud, and then explore options around Espresso and XUI test and any other areas that we possibly extend to in the future.
Well, I'm looking forward to the demo. I know that much because it's cool to see everything in action. This is just I can't say how happy I am because I've been that person, that unlucky one, as Salvatore said, who has to come in the morning and look at all the failures. So it's great. Okay, sounds like we're going to wrap up. I appreciate everyone for attending the session. I think this has been fantastic, and thank you, Alistair. Thank you, Alyssa, behind the scenes. We love you watching out for us all the time, and it's great. Let's get on to the demo. That'll be on the agenda.
Thank you so much.
Thank you.